Welcome to AT Math Academy. Topic for today is taking a 3 by 3 matrix for first, and I'm going to show you how to find out the inverse of that matrix. 5, 6, 12, 4, 9, 8, 2, 1, 7. So for finding out the inverse of a given matrix, inverse, let's indicate this matrix as A, and A inverse is written as A to the power minus 1. It can be found out by finding the determinant of the matrix, 1 by determinant of that matrix multiplied with adjoint of the matrix, adjoint A. And determinant, in my earlier videos I have shown you how to find out the determinant of a matrix. Let me write down the formula for that. Determinant of a 3 by 3 matrix or any matrix is found out by taking one row, any row or column elements, and multiplying the elements with its cofactors. So for example, here we are taking the first row 5, 6, 12. I'm going to take 5 and multiply with cofactor of 5, and 6 with cofactor of 6, and now add 12 with cofactor of 12. So this gives me the determinant for the matrix. And for finding out the adjoint of a matrix, adjoint of a matrix is nothing but transpose of cofactor of the matrix, transpose of a cofactor matrix. Transpose means interchanging the rows and columns of cofactor matrix. Interchange rows and columns, which means the rows, elements in rows are written in the columns and elements in the columns are written in the rows. So let's start finding out the cofactors so that we can multiply the cofactors with the elements and get our determinant. And once we find out the cofactor, we can just interchange the rows with columns and we'll get the adjoint of it. Then we can divide the determinant with the adjoint matrix for getting the inverse. So let's start by finding the cofactors of each element. So let me write down the general formula for the cofactor of an I and j element. Is I is the row and j is the column. It can be written as minus 1 to the power I plus j, adding row and column, and minor of I and j. And what is a minor means? Minor is the determinant of matrix that we get after removing that particular row and column. So say suppose we want to find out the cofactor of 5. I need to take minus 1 to the power I plus j. It is first row and first column. It will be 1 for I and j for 1 for j. Minus 1 to the power 1 plus 1, and minor would be removing the row and column of that element. So I'm going to remove my first row and first column. The remaining matrix would be 9, 8, 1, 7. That would be the determinant. And I'm going to multiply my minus 1 with the determinants. So let's start by finding out the minors for each element here. So minor for first 5 element here is 5 is my first element in the matrix, minus 1 to the power 1 plus 1, and minor would be removing the row of 5 and column of 5. I'll be left over with, I'm removing row of 5 and column of 5. The leftover would be 9, 8, 1, 7. So I'm going to write down the determinant of 9, 8, 1, 7. So let's simplify that later. And let's indicate the cofactor of 6 here with minus 1 to the power, and 6 is my second element. and it is first row and second column. So which is -1 to the power I would be 1 and j would be 2, and the determinant minor would be determinant of removing my first row and second column. So I need to exclude my first row and second column, then I'll be left over with 4, 8, 2 and 7. So determinant of 4, 8, 2 and 7. So let's write down the cofactor of 12, -1 to the power first row third column, and determinant would be removing 12 from the matrix. So we are removing the row of 12 and column of 12, then I'll be left over with 4, 9, 2 and 1. So determinant of 4, 9, 2 and 1, and I'm going to find out like that. I need to find out the cofactors of all of them. So first let me write down the cofactors of each of the elements here: C4, C9 and C8 and C2 and C1 and C7. So these are the elements, and my 4. So let's go back to the matrix. 4 is in second row first column, so I value would be 2 and j value would be 1, and determinant multiplied with determinant of removing 4 column and row. So I'm removing my second row and first column. I'll be left over with 6, 12 and 1 and 7. So determinant of 6, 12, 1 and 7. So like that I'm writing out the 9 -1 to the power second row second column 2 plus 2, and determinant of removing 9 I am left over with 5, 12, 2 and 7. And for 8 -1 power 2 plus 3, and determinant would be removing 8 second row third column. My elements would be 5, 6, 2 and 1. So I can write it down as 5, 6, 2 and 1. And for here last -1 to the power third row first column, it would be determinant of removing that. I'm left over with 6, 12, 9 and 8. So likewise we need to do for 2 more elements. My 1 is in third row and second column, and determinant would be removing third row second column. I will be left over with 5, 12, 4 and 8. And last element is 7, which is third row third column. So removing third row and third column from the matrix, we are left over with 5, 6, 4 and 9. So let's find out the values for these cofactor matrices here. -1 to the power 2, and determinant of a matrix is standard matrix is the formula. I'm going to write it down here. Determinant of a standard A, B, C, D is matrix is product of the diagonal elements AD minus BC, A and D minus B and C. So here it is 9 times 7 minus 8 times 1. Let's simplify it later. Let's first write down the equations here. -1 to the power 1 plus 2 is nothing but 3, and 4 times 7 minus 2 times 8. And next -1 to the power 1 plus 3 here is 4, and 4 times 1 minus 2 times 9. And here to the end we need to find out 6 more elements. -1 to the power 2 plus 1 is 3, and 6 times 7 minus 1 times 12. And here -1 to the power 4, 5 times 7 minus 2 times 12. And -1 to the power 5, 5 times 1 minus 2 times 6. minus 1 to the power 4, 6 times 8 minus 9 times 12, minus 1 to the power 5, 5 times 8 minus 12 times 4, minus 1 to the power 6, 5 times 9 minus 6 times 4. So this is my step-by-step solutions for finding the cofactor of the matrices. Now let's evaluate it. Minus 1 power 2 is 1 and 9 times 7 is 63 minus 8. And here minus 1 to the power 3. Minus 1, when it is raised to the power of odd number, it would become minus, and minus 1 when it is raised to the even power becomes positive. So this is minus 1, and 4 times 7 is 28 minus 16. So minus 1 to the power is 1 and 4 times 1 is 4 minus 18. So let's evaluate it later. Let's first simplify all the steps here. 6 times 7 is 42 minus 12. Here minus 1 to the power 4 is 1. 5 times 7 is 35 and 12 times 2 is 24. Minus 1 to the power 5 is minus 1. 5 minus 12. Minus 1 to the power 4 is 1. 6 times 8 is 48. Minus 12 times 9 is 9 times 2 is 8. Here we can do it 12 times 9. 9 2s are 18. And 9 times 1 is 9. And 1 carried. It becomes 108. And minus 1. 8 times 5 is 40. Minus 48. Minus 1 to the power 6 is 1. 5 times 9 is 45 minus 24. So now let's simplify all these. For getting the cofactor of that matrix, let's simplify it. 63 minus 8 is 55 and minus 1. 28 minus 16 is nothing but 12. It is multiplied with negative 1, so it is minus 12. And positive 1 multiplied with 4 minus 18, which is minus 14. And 42 minus 12 is nothing but 30, but it is multiplied with negative 1, so it becomes minus 30. And 35 minus 24, 5 minus 4 is 1, 3 minus 2 is 1. And it is multiplied with positive 1, so the answer would be 11. 5 minus 12, which is nothing but negative 7. It is multiplied with negative 1, so the answer would be positive 7. 48 minus 108. Let's do it here. 108 and 48. Let's subtract it. 8 minus 8 is 0. And 10 minus 4 is nothing but 6. So this becomes negative 60 because it is subtracted from lower number. And 40 minus 8 is nothing but minus 8. And negative number is multiplied with a negative 1. So it becomes positive. So it becomes 8. 45 minus 24. 5 times 4 is 5 minus 4 is 1. 4 minus 2 is 2. And it is multiplied with positive 1. So the answer would be 21. So these are my evaluated cofactor elements of the matrix. Okay. So let's write down the cofactor matrix by depending on the row elements. So first row, first element, first row, second element, first row, third element. And second row, first element, second row, second element, second row, third element. And third row, first element, third row, second element, third row, third element. So I'm going to write down my cofactor matrix here. Cofactor matrix. So for writing the cofactor, I am taking the elements from the evaluated these corner values here and writing it as 55 and minus 12. 55 minus 12 minus 14 and minus 30, 11 and 7, and next would be minus 60, 8 and 21. So this is my cofactor matrix, and the formula for the inverse is adjoint A, and adjoint is the transpose of the cofactor matrix. So let me write down the adjoint matrix. Adjoint matrix is found out by interchanging the rows and columns. So my first column would become my first row. So 55 minus 30 minus 60. My second column would become my second row. My third column would become my third row. Okay, and the last would be, I found out my adjoint matrix, and now I'm going to find out my determinant. So the formula I have written for the determinant is first row multiplied with its cofactor, and all the elements needs to be multiplied. So I'm taking my 5, and cofactor for 5 is nothing but 55, and cofactor of 6 multiplied with 6, cofactor of 6 is minus 12 here, and cofactor of 12, so let's check. The cofactor of 12 is minus 14 here, so when you simplify this it would be 35, and the inverse would be A inverse would be nothing but 1 by 35, and the adjoint matrix 55 minus 30 minus 60 minus 12 11 8 minus 14 7 and 21. In a simplified way we can write it down as 55 by 35 and minus 30 by 35 and minus 60 by 35 and minus 12 by 35, 11 by 35, 8 by 35, minus 14 by 35, 7 by 35, 21 by 35. So this is how you find out the inverse of a 3 by 3 matrix, and this is a total glimpse of the problem. Hope you all like my video, and please subscribe to ET Math Academy. Thank you for taking time to watch this video, and enjoy doing math at 80. Thank you.